Good news, you don't have to memorize these identities.
That's good.
You do have to remember our most favorite identity from last semester, which is this one. We're going to use it a lot today. So you have to remember sine squared plus cosine squared equals 1, and that we can move it around to use it a little bit easier. But the double angle identities that we're going to do today and sum and difference identities that we're going to do tomorrow are, I'm going to give them to you. I have them on an equation sheet. I will put that equation sheet in front of you for you to use anytime you need it. There's going to be lots of, like, that equation sheet we don't touch because it's not useful first semester, but there are a lot of things with polar coordinates and that we will use that equation sheet for. The other thing I forgot to tell you, you would not have a Math Excel for this, kind of this little quiz, this packet. What you'll do instead is turn in the practice. So there is one practice assignment in here that you will do on a separate sheet of paper and staple together your beautiful work and turn it in. And that will serve as your 10 points instead of just 1. Okay? So we are going to, today we're going to do equations and proofs. So we're going to have to kind of switch between both. Remember with equations, we're getting x by itself, right? We're moving across the equal sign. When we get to proofs, the equal sign is a brick wall. We're not moving across it. And so that's something like, I think on the quiz, I like try to make sections for you. Like this section is equations, this section is verifications. You're not having to like do an equation and then a verification and go back and forth. But just make sure that when you like make the switch and make sure you're dealing with it appropriately. In equations, the nice thing is that all we're adding is the first step. So this sine of 2x minus sine of x equals 0 is actually an equation you've solved before. I think we did like one in notes. We did one just like it. In review, you had one like it on your equations test. You had one like it on the exam review and one like it on the exam. It just didn't look like this. Here's what it looked like. Sine of 2x is the same as 2 times sine times cosine. That's an identity that works for everything. So anywhere we see sine of 2x, we can drop in 2 times sine times cosine. And then we're going to solve the equation from there. What do I do from here to solve this equation? Absolutely. What do these two have in common? X. So I'm going to take out a sine of x. Remember, especially GCF is just fancy division. When I divide a sine of x out of my first term here, I'm left with 2 cosine of x. When I divide a sine of x out of here, I'm left with 1. And now you have 2 little guys you can set equal to 0. So this one, 2 cosine minus 1, so add 1, divide by 2. And now we have to think unit circle. Where is sine 0? Zero on pi. Cosine is 1/2 at our thirds. cosine is positive in quadrant 1 and quadrant 4. Do you know circle still in there? It'll come back real fast if it's not. If you put like, I don't know, 10 minutes into it during house today, it'll be right back. A little bit of maintenance. Okay? So our first step with these, with the equation, applying the identity is just going to be, it's going to be the new first step. It's not really going to impact anything in your solving equations above and beyond that. So now let's put in cosine of 2 theta, or cosine of 2x. Do you guys have a question on that one before I move on? No. Okay. Cosine of 2x is the same as cosine squared minus sine squared. And then I'm going to keep everything else the same. Minus 1 equals sine squared. And now we just solve like normal. So I'm going to get, since I see squares all over the place, I'm going to get everything onto the same side of the equation. And I can do that most efficiently by just moving this sine squared over. So that gives me cosine squared. I have a negative sine squared and another one, so that's minus 2 sine squared. And now I have cosine squares and sine squares, and I'd rather just have one that I'm working with. Since this guy is on its own and positive, I'm going to take cosine squared and make it into 1 minus sine squared. If you would rather work with cosines, just be careful. You can do that. You could put 1 minus cosine squared in for that sine squared. Just put it in parentheses so that you just end up distributing that negative 2. Okay? Either way is fine. Again, there are lots of ways to make these happen. But you just got to be careful there. This color coding, and I forgot. There we go. And then you can combine your like terms and solve. I have 1 minus 1. So those are on. I have negative sine squared and negative 2 sine squared. So that's negative 3 sine squared. It's a little easy to overthink this one and think you should have more going on than you do. So when we divide that negative 3 over, we just have sine squared equals 0. So that gives us 0 and pi. Those are answers. Again, to equations, I can't really think of a way that this is going to impact an equation other than just give us a different first step. Give us a swap to make in a first step. When we get to verifications, it's usually either going to be our first step or our last step where these make an impact. So So we've done a sine of 2x, we've done a cosine of 2x, we got to do a tangent. Of course, when we expand for tangent of 2x, of course, it's going to make a fraction, because tangent always makes a fraction. So I'm going to put that in right here. If we can get rid of fractions, we want to, right? The first thing we want to do if we can is clear the fraction. How can I get rid of this fraction? Remember, this is an equation, so we can move things to the other side. So what can I do to both sides?
Multiply them by 1 minus tangent.
Absolutely, multiply by 1 minus tangent squared. If this was a proof, we could not multiply by both sides. We'd have to do some fancy form of 1 or something. We wouldn't be able to get rid of that quite so easily. But here, if we multiply the left side, we cancel the fraction. What we do to one side, we have to do to the other. And that is a negative tangent of x that you're going to be distributing on the right side. That's your next step. When we distribute that negative tangent of x, so be really careful with your signs. Negative tangent times 1 is a negative tangent. Negative tangent times negative tangent squared is positive tangent cubed. And since we see something that's a degree greater than 1, we want to get everything onto the same side so that we can factor. So I'm going to subtract that 2 tangent of x over. And then what can I GCF out? A tangent. When I take a tangent out of the first term, I'm left with -3. When I take a tangent out of the second term, I'm only taking one of them, so I'm left with tangent squared. It's good to do some tangent in that circle. No. Sine and cosine was okay. So now we can set these both equal to 0. I actually think tangent equals, for me, tangent equals 0 is harder for me to get through than this is. Because here, if we add our 3 over and take our square root, when we take our square root, what do we have to have? Oh, thank you. So tangent is radical of 3 at all of our pi over 3's. So we want every pi over 3. So pi over 3, 2 pi over 3. 3 pi over 3 is pi. 4 pi over 3. And 5 pi over 3. tangent of 0 is harder for me. I have to take tangent and make it into sine over cosine. If you haven't memorized that, phenomenal. Good job. I have to make it into sine over cosine. I also know if tangent 0, 0 is on top, and it doesn't matter whether cosine is positive or negative. So really, I think tangent is 0 where sine is 0. And we've done that twice already. That's at 0 and pi. Having taught this already last period, I think what everybody agrees was the proofs are actually a little easier than these. They end up being fewer steps. You're led a little bit more because you know what your answer is going to be from the start. You don't have to think unit circle. So proofs are going to be a little bit nicer in a minute when we start. I'm not going to do this guy because we've already done a cosine of 2x. If you want to break down the answers and come back to it when we have some minutes at the end of class, you can. If you want to not come back to it, that's okay too. It's a good one though. And now we're going to do some verification. Do some verifications on the back. So remember, the way the verifications are different is that your equal sign is a brick wall. So the things we can do, we can swap, right? We can make substitutions of things that are equal. We can multiply by a fancy form of 1. That's really it. You can start with either side. I'm actually going to show you an example here in a minute where this first example, we're going to start with the side where we have the thing we can expand. That's usually what I try first. Because if I have a swap I can make from an equation sheet, life seems good. A lot of times, if you get one step going, it kind of things start to happen for you. Sometimes that swap will be your last step too. So I'll show you how that works in a minute. This one, I'm going to work with the left side, and I'm going to swap in sine of 2x is the same as 2 times sine times cosine. So that's the swap I'm going to make first. And that is an identity. It works for every value of x, which is why we can use it in equations and identities. And just like with equations, basically now this is a proof that you could have had 3 weeks ago. We've done the new stuff. Now we're just going to make this equal to 2 minus 2 sine of x. The next swap we need to make is this guy. What's cosine at the same time? Awesome. And you guys know if I have one fraction, I like to make everything else a fraction too. So when I bring this stuff down, I'm going to do this 2 sine of x cosine of x all over 1. I think it's really helpful if once you start introducing fractions into your problems, just make everything a fraction. See anything that cancels? Yeah. I have a sign on top and a sign on the bottom, and it's all multiplication, so it's totally legal. Would not have been legal if I had addition somewhere in there. All multiplication, remember canceling is division. So I have 2 left over. I have cosine times cosine. How can I rewrite that? Cosine squared. And now is a good time to bring down my goal here. My goal was 2 minus 2 sine squared. change the cosine squared too. Yep. And again, this is a really important place to use those parentheses. Anytime you're dropping in for cosine squared or for sine squared, and you have anything out front that's not just a positive 1. If you have a negative, you've got to drop it in parentheses. If you have a number out front, you have to drop that in parentheses. And then, you got it. Like that. You guys fighting a bad sleep schedule you got on last week?
Yeah. I'm still down. What did you say?
The worst thing you can do tonight, or today when you get home from school is take a nap.
Yeah. What? It's gonna really?
Don't do it, because then like you'll take a nap, and then you'll stay up, and then tomorrow is going to hurt worse anyway. Don't make it hurt even worse, because you can't fall asleep until like and then I went back to sleep. And I got all right, here we go. All right, so this one is a really great example. Here we go, come back to me. This one's a really great example of a place where it's going to be best to use our new identity as our second to last step. Because I was really excited. I found this proof brand new this year. And I was like, oh, cosine of 2x. Cosine of 2x is the same as cosine squared minus sine squared. Cool. And then I'm looking at the other side and I'm like, yeah, I don't know how to get cosine squared out of that. So you know what I did? What? That is going to be my second to last step. Because I know cosine squared minus sine squared is the same as cosine of 2x. And it's useful to know where we're going when we're doing proofs, right? Like, we can work these kind of forward and backwards. Middle steps, yeah.
Did you say we're back to the
No. You do not have to write the one. Okay? So, now I have my last two steps. Let's figure out what to do with these guys up here. What's really useful about knowing that our second to last step is cosine squared minus sine squared is that I know I need to put that stuff in terms of sine and cosine, right? That's almost always the most helpful thing to do when we're working with proofs anyway. So I'm going to make cotangent squared cosine squared over sine squared. And I'm going to make cosecant squared into what? Which reciprocal is that? Yeah, 1 over sine squared. Awesome. Don't be freaked out by the fraction over a fraction. It'll only be there for a minute. Now, in the numerator, I can't flip the second and multiply until I have a single fraction up here. So what do I want to change what's my 1 going to turn into? Yeah, to get that common denominator, I need sine squared on top and sine squared on the bottom. So hey, remember our goal was cosine squared minus sine squared? Do you see it right now?
Oh, yeah.
It's there. It's there. That's our goal. So we're going to leave that numerator alone as much as we can and just try to get rid of everything else. So I'm going to rewrite. My numerator is over sine squared. We made that common denominator happen. I have cosine squared minus 1 sine squared, but sine squared. my denominator is at 1 over sine squared. And then however you make these signs cancel, a lot of you like this. Flip. Some of you like this grouping situation. I'll write the flip because that's what most of you, I think, like. And then you fill in your blanks. You got it. So I always look for that double angle, or tomorrow when we're doing sum and difference, I always look for how to apply that first, whether that ends up as the first step of my proof or the last step of my proof. It's usually one of those two, but it's helpful either way. I like that one. I like that one. Okay, one more for us to do together. So similar to the last problem, when I look at sine of 2x, sine of 2x is the same as 2 times sine times cosine, so that's lovely. Any way to get 2 tangent over 1 plus tangent squared out of that you can think of? Just off the top of your head. Yeah, I don't think so. So I'm going to grab it. I'm going to throw it to the bottom of my proof. And I'm going to keep an eye on that as my goal. There are a couple of different ways you can do this one. I had somebody working this problem last period who did it differently than me and got there quicker, actually, which is cool. When you see tangents, what do you want to do with them?
Cosine, sine.
Yeah, change of the sine to cosine. So the thing you want to be careful with as you're doing with that is if you change tangent into sine over cosine, that 2 out front is a 2 over 1. So the 2 is on top with a sine, and the 1 is on the bottom with a cosine. If you make it 2 over 2, you've just broken your problem because you just made it into 1. So, and sometimes we will do something like this. And that, putting that 2 out front, you are putting off where to put that, right? When you go, I don't know where this goes. I'm going to write it out front. Decide later. That's okay. You can just get there. It goes on the top down there, right? So don't put it off. You know where it goes. Put it on top. This is fine. Okay, get a step out of me. What do you want to change the 1 plus tangent squared to? You can change it to sines and cosines. I mean, you can change the tangent squared to sine squared over cosine squared. Oh, or you could change that. Secant squared. I like it's really
Secant
nice.
squared, yeah, that was really stuff.
This is secant squared. That's really nice. You can get there by sines and cosines, and actually that's the way I did it on mine. So if you want to do sines and cosines there, I can take a look at it. This is fast. Okay. So that's 2 sine over cosine over, and secant squared is the same as 1 over cosine squared. So if you are working with tangent squared, this tangent squared is sine over cosine. Here's what the denominator looks like. And then you do and then you're there. So if you don't see that 1 plus tangent squared is secant squared, and you just change that to sines and cosines as well, that's actually what I did the first time I did this. You just have to get that common denominator, and then cosine squared plus sine squared is 1, and it gets you right there. So both ways, lovely. I like using cosine squared plus sine squared equals 1 anytime I can, so I wasn't mad that that happened. So that's just that's the bottom of the fraction.
I'm next time.
If you use sines and cosines
You're not
instead. All right, now, between now and the end of class, work on these 3 problems. They're nice ones. They're on the bottom of your page there. What I would actually do first is not look up here and do that verification problem, because that's what's like fresh in your mind after doing those proofs. Let's put it up here. It's color coded and it's Friday. Try tomorrow.